I do.
Good, good, good. You are coming to Toronto on what day?
I'll be landing there on Tuesday morning.
Yes, okay. And yeah.
How's the weather now?
Very
Sometimes
good.
it says that it's thunderstorm and all that, and sometimes it's saying that it's very hot. Feels like 37 degrees or something.
It is actually very nice weather.
Okay.
Yeah. Yeah.
Okay, that's nice.
Basically, yeah. I mean, this is the only time I have gone for a walk. Okay. In Canada in the whole year. Okay.
No, they say whenever it is sunny and nice weather, you have to
Hmm.
go for a double walk so that you can accumulate your walks, because once the winter starts, right, you will dread going out of your house.
Yeah, yeah. The summers earlier were so bad. Yeah, it was pretty bad actually.
Okay.
Because it used to burn a lot. You could not get
Yeah,
out. Hmm.
exactly. If you compare with India's, yeah, if you compare India's weather, right, it is humid there, right? So it doesn't burn up. Here with 21, 22 degrees, right, you can't go in the sun. It's so bad. It started, burning your skin is bad. Not that good.
When I went to Singapore and I met Aureline. Okay, Aureline is from Montreal. Okay. Aurelian, that guy whose book is there, right? Aurelian Geron.
Yeah, yeah.
So he told me that he's from Montreal
Hmm.
and he finds Singapore's weather really, really hot. So when he came to meet me for coffee, he was like very, very upset with the heat. He was saying there was too much heat, too much heat. For me, it was normal. So people from here, they find the weather to be too weather of Singapore to be too hot or India's weather to be too hot. But for me, it was just normal. Okay. But when came here, it just skin burns here. I do not
Yeah.
understand. I
It
have
is. I think because the weather is very clear and you get a lot of sunlight, direct sunlight. I don't know, but with
exactly.
21 degrees, right?
Hmm.
In India, 21 degrees is good, right? I mean, my AC used to be on 20, 21 degree, right?
Yeah, yeah,
So
yeah, yeah.
21 degrees is also good. But here, 21 degree, you really get, it's
Yeah.
bad. You can't
It's
walk in the
burn.
sun.
Yeah.
It's that bad.
Yeah.
Is there
I
a
think
ozone layer issue there, Sandeep?
I don't know. I don't
no,
know.
the
Like
issue is this, okay?
Australia people, yeah.
Hmm. Issue is this, the
Like I'll
Earth is tilted.
okay,
Okay.
you finish.
Okay,
Yep.
Earth is tilted, and that's why here Earth is closer to, like we are closer to the sun, like Canada,
Hmm.
because of which the intensity is really high.
Hi. Okay.
Yeah.
Okay.
That's,
Australia,
I
like
think
here
that's
we
the
have
reason.
this ozone layer issue, so they
Ozone layer
don't
issue is
allow.
also there. That's
Yeah.
also there.
So people here don't allow kids even to play outside in a school without like sunscreen and all.
Definitely, because every
Yeah.
day people, before going out, they check the UV.
Yeah,
Mm,
like a lot of Europeans and
yeah,
Canadians
yeah.
moved
And
to
then the
Australia
thing is
because of
real.
sunlight
Now
and
I realize that that thing is real. And I was laughing when I came here that why do people keep on putting all this cream? But then I realized that, oh, it's actually terrible. One day,
Disadvantage. Disadvantage
yeah,
of having very clear, non-polluted air.
yeah, yeah,
UV rays doesn't filter out.
yeah, yeah, that's the thing.
lot of I mean people from Canada and Europe moved to Australia actually because of sunlight and weather. Here
Mm.
normally even in winter temperature it remains around
I
I mean
mean,
temperature of
honestly
Sydney it's
speaking,
around around like 18, 20, when summers are like 30, 35, like hardly 2-3 days temperature goes above 40 in a year. Yeah, sorry, someone
You
else
know,
was saying.
no, Rahul, one weird, I won't say weird, but one different thing about Australia is that you have summer in December, which we haven't
Yes.
heard of, right?
Yeah.
December is
The
summer,
weather is exactly opposite to Canada or
opposite.
India, whatever you can name it. Yeah. Yep. So here we are like in the middle of the winter at this point of time. And I know there is a bushfire in Canada as well. People from Australia are going there to save Canadians from like
No,
they
it's
had a
bad. The
collaboration.
entire town is sort of getting wiped out. It's so bad.
Yep, it's happening.
The forest fire. Yeah.
And you will see then, after bushfire here, you'll see roasted kangaroos on the highways and motorways. Yeah, like kangaroos are 10 times, 20 times more than human population. Yeah, they just get burned out and you can see them. Anyways, yeah. Let's get back to work.
Okay. All right. So let's get started with this. Okay. Some of these things might look very obvious to all of you, but the interesting part of the thing is that the same question I have been asking the data scientists for some time. And it's very interesting that even very experienced ones make these mistakes. Okay. So I'm going to. Did anybody try this sentiment analysis? Today, I want to do a little bit of sentiment analysis. Okay. And yes, this is a very, very rudimentary, basic thing. It's not really a machine learning. It's a simple Python things. And yeah, so there is a library. There's a thing that he has done. Okay. And so on with LLM, with OpenAI, and LangChain, text to SQL. Okay. All right. You can see GPT from scratch. My data engineering, Python. Where is my notebook? Just give me a moment. I will take out. Yes. I will download it to my home directory and then we will walk you through. Okay, perfect. And I don't think that it's a thing where you require a lot of you require a lot of work for this. Okay, and what I'll do is I would just open this notebook. Let me set up my environment. Okay, there you go. All right. All right. So good. Let's start here and then we will go from there. Okay. So yes, I'm assuming that all of you are good with Python syntax. Is that a fair assumption? Can I assume that all of you are comfortable with Python syntax? Maybe you are having difficulty in framing logic, for loop, I mean, the framing, the recursion and all of that. I understand that's going to take a lot of time, but can everybody just raise the hand if you're comfortable with Python syntax? Like what's a function, what's an expression, what's a statement? Just please raise your hand if you're comfortable with Python syntax. When you look at the Python code, you should be able to figure it out. Please raise your hand if I can see only. Please raise your hand, everyone. All right. Okay.
I am not very comfortable yet, but that is because of me. I have not practiced enough or actually at all about Python. But I know programming logic and stuff. So that's
okay. Good. But syntax you're okay, right? With Python syntax?
Syntax is the basic syntax, obviously that is like any other programming.
Yeah, that's all I wanted. Okay.
By the way, I read this sentimental analysis, this blog that you had shared. It's amazing. It's very, very interesting.
Okay. Good. Please, everyone, please raise your hand if you are comfortable with Python. Okay. Deepak Gupta? Yeah. Please raise your hand. And I can't see your hand.
Okay, one second. I've logged. I just
Okay.
returning from my badminton.
I know Veena knows very well. Subodh knows. So even if you're not raising hand. Somasri, Siddhartham, are you guys I just want to understand if you guys are okay with the syntax of Python. When you look at the code, you can say, okay, this is what's going on. If you're comfortable with the syntax, just raise your hand. I just want to see if there is anybody who is left behind.
Sorry, I somehow is missing the option to raise hand in my Zoom. I don't know why. But yeah, I'm raising hand.
Okay. All right.
Sandeep, I do understand now Python and whatnot, but again, my confidence level is not there, especially with data structures. Actually,
that's okay.
I don't know if I need to practice more on those things, but
there is
basically, I don't feel comfortable there.
Basically, all you got to do is just solve more and more questions from, say, LeetCode or any of the online contests, or take up any book and just start solving the questions, and that's it. That's the only way to gain that confidence. And like the amount of time you spend on solving problem is what will build your confidence, not the number of problems you solve. If you are not, let's say you are just looking at solutions and then solving them, okay, that's not solved. Okay, so struggle with it. No need to watch the solution videos, no need to do anything. Just go with first principle. Just try with your raw talent and just try to solve with the logic that you have learned. Okay, the fight, put that fight into that place. Don't have the mindset that, oh, I need to study these 20 chapters in order to solve a problem. Jump into it. Give it your raw try, because in 99% of the cases, most of the problems people can solve by themselves without studying a particular, particular data structures book. Okay, most of this is common. Okay, so don't have that mental block that you have to first finish all of that. No, just go with first principle. Just like a kid, just like a child, just give it a shot. All it requires is the amount of hours you spend on trying to solve a problem. Okay, that is my request to everybody. Not the amount of time that you are watching videos on people solving problem. No, amount of time that you are struggling and fighting and debugging and trying one logic, another logic, and then deleting it, writing another logic, and then struggling through it. That's the phase that would change you forever. That will give you this amazing confidence. And what I usually do is, as a habit, okay, I have something called a Pomodoro style. Did I tell you about the Pomodoro style? Everyone? No. Okay, so my strategy of doing things is pretty simple. Okay, and first thing is that my strategy is that, okay, that I build a external force. Okay, if I have to achieve something, I design like external force that I cannot deny to. Okay, like if I have to prepare for let's say I had to prepare for interviews. So what I did was I applied to 10 companies, and this long back. And then I basically scheduled interview and requested for 2 months time. Okay, 2 months gap for preparation. Now, since I have this interview hanging on my neck, I basically am bound to prepare for it. So that's an extra, like crafting an external force for yourself. Okay.
Yeah.
And that's a very most important thing I found. Like when I quit my first company, when I quit DE Shaw, and I started a company called T-Bits, for 6 months, I was just sitting on my bum and doing nothing, just sitting there and believing and convincing myself I'm doing something. And I'm reading this blog, reading that blog, reading this design pattern, that design pattern, and thinking that, oh, I'm doing research. Okay. But I wasn't much. Okay. Until I basically focused on one problem and committed to somebody that we will be releasing this thing in 2 months' time. Okay. So crafting an external force for yourself is the most important and intelligent thing to do. I have seen so many smart people from my class. They haven't learned new thing. They haven't been able to push themselves out of their comfort zone because they did not craft an external force for them. Okay. And that's a most important, like having this class is one external force that pushes you into this studying something. The reason I joined JEE entrance exam, JEE preparation exam tutorial was because of the external force being there. And now also I follow that same principle that if I have to do something, I have a external, like yeah, I think most important part in your entire process is to craft an external force for yourself. Okay. Like, I mean, whatever way you can do. Okay. Because the body will remain in stationary position until and unless an external force is applied. Okay. That's the most important. Okay. The second thing is, once you have decided on something and you know you have to achieve it, I follow this Pomodoro technique. Okay, Pomodoro technique. Okay. And what I did do is I'll show you what I have. Right? You see,
what is that actually? Never heard of.
Yeah. So it's a physical timer. It has 3 timers in it. Okay. I found it in AliExpress. It has 3 timers. Okay. So one timer is of 25 minutes, another is 5 minutes. Okay. So what I do is I turn off my phone. I keep my, if I have to just focus on building something or doing like focus way, right? So 25 minutes, complete focus, right? Okay. No phone, no water, nothing. Okay. Don't think about anything. Just think of one task at a time. Okay. And then mandatory 5 minutes break. Okay. Finish all the things that you got to do. And if something distraction comes in and you feel that, oh, I should not forget it, just make a note of it. Okay. And finish that task in that 5 minutes. If you have to make an urgent call or something. And then again, 25 minutes and then 5 minutes break. Okay. I do not do it on the phone because phone is very distracting. And there are apps to do Pomodoro technique on phone called Focus and all. But what happens is the alerts keep coming and you kind of get lost on the phone, open the Facebook and you open Instagram and then you get lost. Okay. And then again, 25 minutes. Okay. And 5 minutes break. No, this time it's 20 minutes break. Okay. So yeah,
third time 20 minutes. Okay.
20 minutes, right? No, 4 times, and then 5th time is 1, 2. 1 second. 1, 2, 3, 4. Yeah, yeah. After this, you take a 20 minutes break. like lunch and stuff. Because by the time you finish this, you'll be in the lunchtime. Okay. So, and then you again start. So I think
It's like,
yeah, it's like aggressive way of managing yourself, because today, right, the biggest challenge that each of us have is the focus. And like all the social media, all WhatsApp, all of these things are trying to gain your attention. And you have basically, you have to give up on your attention. That's what all of these tools that do to you. So you have to just be extremely selfish and fierce and singular focus. When you are working, just work on one thing at a time for 25 minutes and then do that. Okay. And only then you will be able to achieve something significant. Okay. If you are just jumping from one task to another, what happens is your context switches so much that you are not able to give your full attention to something. Okay. And I follow this very much, right? When I was building Saturno, when I was building any of the courses, anything that I do, I have to sit down and do basically just this, right? In this time, I do not talk to anyone. I do not listen to anyone. And yeah, I do not have a single tab that is open for anything other than the task at hand. Okay, so that's my style, I think, and it works. It's something that most of you would be having, right? So both, I think you would be knowing all of this, right?
I mean, I didn't know about this Pomodoro technique, but this is what, based on my habits and my work, and especially working with Amazon, right? I had this timer, right, which I have just in front of me. So every time, what I do is I put a timer for 1 hour, and
Yeah,
whatever task I take, right, whether it's writing a doc, sending emails, doing coding, anything, right, for one
yeah,
hour, just complete that task, and then
yeah.
take a break, get out of the chair, move for like 5 minutes, and then take 30 minutes task, right? And then
Okay,
do it that way. So I used to do 1 hour, 30 minutes, first
okay,
1 hour, 5 minutes, then 30 minutes, and
okay.
then maybe do things which are required, smaller, quick things, right? Sending an email, sending a note,
Yeah,
talking to somebody, call somebody, and then again do 1 hour, break 30 minutes. So in a day, if you're able to do 3 cycles, right, you end up giving 4.5 of dedicated work, right? Trust me, 4.5, 5 hours of dedicated work, you can move mountains. All
yeah,
right, you don't need 10 hours of work, right?
yeah,
But whatever you do, you need dedicated four and
yeah,
a half hours work.
yeah,
You
yeah,
can do
yeah.
really
So
good things.
I had earlier a very bad habit that I would take a break whenever I'm stuck. Okay. And what used to happen is, right, I would take a break of various kinds. Like I'll go for a smoke, I'll do this, I'll do that, I'll have that, right? So what used to happen is my problem solving, what used to happen is when I see a problem and I'm thinking about the problem, I would take break. Okay. And that's a very bad habit. Okay. So instead of learning to solve problem, my brain learned to
learn
take
to
break.
take break.
Yeah, I remember in one of the interviews after the show, okay, me and interviewer both went out for a smoke in the mid interview. Okay, he asked a question. He asked a question, and I was thinking that I should like to solve a problem, I need to smoke, and then I got out to take a break. And yes, that's actually very true. I'm being very honest. Okay, and it's a real story. Okay, so the important part is don't take a break when you are stuck. Okay, if you see, my philosophy is if you want to solve problems, and you'll learn to solve problems. If you are want to uh, get heart disease, then what you do is on every problem, take stress. Don't solve it. Just take a stress. And that way you'll just learn to gain stress. Similarly, if you, right, I see many people shouting and all of that on the phone. I used to do that earlier, but I don't do it anymore because it I only learn to shout. So anything that you do, you become. So if at a given a problem, if you just solve it instead of taking break, you will learn to solve it. If you take break, you will learn to take breaks. And that's a very interesting thing that I've discovered. So take a break, mandatory break. That's a very, very, very important clause. Okay, mandatory 5 minutes break. Why? Because you are taking a break not because you are stuck in a problem, but because you have it's a normal thing. So you will learn to take break without impacting your problem solving. Because if you have like mandatory breaks, okay, don't take a break. Don't build this habit of taking a break when you are stuck. Okay. And I mean, this is a very, very important and critical thing to think about. Okay. So first is like craft an external force for yourself by committing to somebody, by announcing to the world, by signing up for something, having a social routine, having something else where you cannot avoid it. Like I take lots of meetings from my treadmill. So because meeting is going on, I can't get off the treadmill. So it's an external force. I keep on walking on that. Okay. So create an external force. Then do the Pomodoro technique where you have the complete focus on things. And next thing that is a good hack is that I maintain a list. Okay. So I'm reading something. Let's say I'm studying a linear regression. Okay. And in the midway, some keyword come in. Okay. Some keyword come in. And I'll just seek its quick meaning and then park that aside in my reading list that, okay, neural network, I'll read later. So I'll put it in a reading list. And then again, basically continue moving. So until and unless I finish linear regression, I'll not jump into the neural network. Okay. The bad habit is that we started linear regression. We went to neural network, then came back to linear regression, then went back to the neural network, and we keep on jumping, and we do not basically build confidence in either. Okay. So a good habit, you are reading linear regression. You see the formulas and everything, and you then encounter a term called, oh, this can be done better with neural network. You make a note that, okay, I'll read neural network. Let me just focus on finishing linear regression. And then you'll basically do that. Okay. So maintain a to-read list and don't jump too much. Finish one thing at a time. And you'll be amazed that this list will have, let's say, 100 items. Okay. Amazing part. Okay. So it has, let's say, 100 items. Let's say first one is linear regression. Okay. And the second one is, let's say, linear regression. Then, let's say, what is, let's say gradient descent. Okay. Like that. Let's say you have this list that I need to finish this thing. Okay. So initially this list will look too long for you because you don't know what is duplicate and what is not. So this might have like hundreds of items. Okay. The list keeps on growing. And as you start finishing one topic at a time, you will find these items to go to drop from this reading list instantaneously. By the time you finish like 4 topics from it, and you'll like your entire reading list will be over. Okay, that's the amazing part about that. Okay, and if you do not focus and finish one item, the list will not end. Okay, if you keep jumping, the list will keep on increasing. If you finish one topic focused way, you'll see that list will drop logarithmically. Okay, it will just drop logarithmically, as in because one item makes you learn so many things that a lot of items will drop from your list. And this works for me very well. Okay, so this is this is a thing that I always recommend, and this is what separates, what separates one person from another. Are you able to create an okay? And right, because if you're stuck, let's say you're stuck in a well, right? You can't lift yourself out of the well by yourself, correct? So you have to design an external force by the way of some other person or a tool or somewhere. And right, if you get a pulley, get a rope, you can have that. But in real life, it's very hard. So it's generally people figured out that if you ask help from somebody else, that's an external force. Okay, so design and craft your own external force to achieve anything. That's true for everything. Okay, so that's my way. And yeah, you were saying something.
Yeah. Hello.
Yes, Madhumita.
Actually, I have one question. What happens like this is okay because you are doing multiple jobs, right? And you have family also, kid.
Yes.
So what I feel is difficult to like if I have to do the work from office, but I have something in my list for my personal thing, right? I have to read something but whenever I will get time, I will think, okay, from office I have to finish this. Always I am doing office work. So that to-do list for personal growth or something, it is always I am skipping.
Yes.
That's why I find this class also, because if I am joining, then at least I will do something for me.
Yeah. One thing I can tell you,
how do you
like being
separate things, kind of how much time you give for one job?
Yeah, actually, this is a very difficult scenario, Madhumita. I would ask Rahul and Subodh and other people.
Yeah, I got like 3 kids. One like last 2 ones are twins. So I mean, I just finished my MBA. How I did it, like I wake up at 3 every day.
I see.
3 to 7, like a pretty calm period. Everyone is sleeping, and I'm doing whatever is needed to be done. That's how I do it. Yeah. Otherwise, like daytime distraction, dropping kids, wife going to office, coming from office, picking kids, me, cleaning, like everything you have to do it here, like by yourself. No one is here to help you out anyways. So life get too busy with kids. The only time is like 3 to 6, 3:30 to 6. That's what I use it like every day for whatever I do. For if I need to go to gym, that's the best time. In between that, I can pick anything. If I have to study, I need to pick that time. That's my own time that I use it every day. Like otherwise,
so one thing which I have learned from my ex-manager, he's a PhD holder and he's currently heading a pretty big AI startup in India. So what he said, and this is specifically to work-related learning, right? I think Madhumita and Sandeep were talking about how you can start learning things which is required for a job or other things, right? Not exercise or other things. What he said is that you go to job, you work for 8 hours, right? You have to figure out how you can spend 1 hour to upskill yourself during the job itself, right? I have seen him setting up a meeting for himself in office, saying that I'm going to learn something, I'm going to read something. I understand people think that this is being not fair to the job or anything, right? You will not learn if you don't do this. If you learn, you're going to do good in your job. So as a manager for last 20 years, I have told the same thing to all my reportees, is that if you want to learn, don't think that you'll do it in your personal time. Your personal time is your personal time, right? Block calendar in your work schedule itself, saying that you want to learn, right? That way you will be doing job, you will be doing your work. Try to learn something related to your work, or create a scenario where you have to do that. There's no other way to learn it, right? And it doesn't work. If you say that I will spend Saturday, Sunday learning something so that I can do it, it doesn't work practically. I have seen people doing that. I mean, they're very good. Practically, it doesn't happen. Everybody has family, everybody has kids.
I like that. I like that. I think, see, at the time of like even now, I basically have realized that there is just too many things that happen, and I go strictly with my Calendly, and that's also a good hack, right? So basically, if people need attention and all, I basically just share my Calendly, even with close friends, and like if I have to go to swimming, I put it on my calendar and I block it. And then if I have to read a book or read something, I'll just put it on my calendar and say that I'm going to read something. And people will find alternative times to it. And I think that's a good hack. Yes. And that's very difficult thing. Uh, it's very difficult thing for I'm not for people to people, like for Madhumita there would be many things, right? The kind of attention the children will demand from my wife is very high as compared to me. Yeah. So for me, saying this is a different thing, but and it's a difficult thing. Well, it's a difficult thing, and somebody, I mean, if you find a good solution, Madhumita, do share with everyone. Okay.
Yeah. I think like it depends on case to case. Like I can tell you, like my kids were not even one when this COVID happened, right? So I work from home while my wife keep on going to office. She still do every day. So I was the one like doing a motherly responsibilities for them, even changing nappies and cleaning shoes, whatever you can call it. So I was the one who used to do it. So like that's where I see, like if I have to do something, I have no other choice to do it like before hours. While working, yes, I work, do whatever I need to do but at the same time, I need to, take care of kids as well. And even if like still they now start going to schools and preschools, so I had like a responsibility of dropping them up, making lunch and blah blah blah, because my wife's job start at 5. So I need to make sure by 7 I'm up and away from my bed actually and doing things for them. So that's the only time I found it. But again, as I said, like there's no right or wrong way. It all depends on your situation. You just need to make a time for yourself.
I would like to add one thing. So maybe writing it down what all things you will be doing one day, that has helped me probably very much, because I am a mother of 3 kids. And I have a job. I'm a software engineer. I technical lead at what company. I have homely responsibilities. I have to buy groceries, everything. So everything and I'm taking 1 hour to study every day. So everything I am able to do. I do 1 hour of exercise every day. So everything I'm doing only I write down, like from this time to this time what I'll do. So I try to follow that as much as possible. That is how I am able to do. Otherwise, I was for a long time I was not going for workout. I was not going for not doing any external learning. So I thought, well, how can I do it? Then I got this idea. I'll write it down. What is my available time? Is this time right for me? So then when I look at my diary, then no, this is the time which I can utilize. Otherwise, I'll spoil my time. That is what I
that's the thing, right? Like whatever works for you, and you have to focus.
I sent a book in the chat, Uptime. I highly recommend it for folks. It's by a Google executive. It's actually practical guide to managing your calendar and making sure you have time. So what Subodh was saying about using time in the office, I guard my time now. I have an admin assistant, so she's able to manage my calendar, but I have blocked time where she is not allowed to set meetings up with people that I'm supposed to meet unless and until I approve. That creates the time that I need to study in the office.
Nice.
Yeah, but if you're running a small business in India and you're in sales and like customer facing roles, it's like extremely difficult to follow this Pomodoro technique. All these techniques, everything goes for a toss.
Yeah. Basically, actually, the nature of job dictates a lot. Like how much time.
Dictates a
and
lot,
right, I'm seeing that, like in case of say like one of the clients that I talked to is like a company called Data Valley. I'm working with them. They work for 7.5 hours. I mean, not more than, not even a minute more than that. And then they keep Fridays off in summers, and Friday afternoons off in summers, and there's a 1 month vacation. So it's like kind of mandatory requirement in these countries. So I think nature of job and the culture of the company dictates a lot. So sometimes things are not in the control. So you can't do much, but just figure out what are the things that can be done in that constrained environment and figure out how to do it. Because as Veena said, that writing it down actually helps you solve and think about your current state and gives you ideas about how to handle different scenarios. So I'll move the writing down to the top of the list. And yeah. Anyway, so I think yeah, this was a bit of digression, but I hope it was useful to all. And this is something that I think most of you are also quite experienced and can share it on the group. Okay. And it's a good thing. It's a good thing that I mean this is a very important part of you know, managing your own learnings. Okay, because what we are trying to do in the as part of this course is that we are changing ourselves, right? Definition of ourselves. We were non-programmers before the course, now we are programmers. So we are kind of just changing our definition. And that change cannot happen without these social hacks, right? The one that we just discussed. So I think all of this is a part of the course, and yeah, and I think you guys, everyone can put in their thoughts. I'll put these notes in WhatsApp, and you can also chime in. All right, perfect, very good start of the session. Let's start. So one thing I'm going to do is, since this is from the general talk, okay? Yeah. Now, I'm just going to just jump into the large language models, okay? So we all are used to ChatGPT, right? Everybody has used ChatGPT, and right, and everybody knows that it can generate things. Now, there are two ways to use large language models, right? One thing is, give it text like a question, it will generate a text response. Correct? This part, I think, this part everybody has done well. Okay, everybody knows that this part is a common thing. Correct? This is a use case that you have been doing. That give it a text, and it will give you, this is your question, it gives you an answer. Correct? Now, there is another slight modified version of the same large language model. Okay. You give it a text and it returns bunch of numbers. We call them embeddings. Okay. You give it a text, it gives you the embeddings. So the OpenAI's LLM provides two APIs. One for getting the text response, other is for generating embeddings. Okay. What is API? Basically, they have provided like a URL, which we can call, and then you can basically get a response. Okay, right? Those who are new to this, just also quickly just walk you through. Not this. No, where is my? There was Python one, right? The one that we opened yesterday. Why it is not showing up? Okay, I'll just say presentations. Okay. those who are new to this, I'll just finish one quick chapter before this, and then we'll talk about this one. Okay. And where is my regular expressions? This one. Okay, yeah. Let me just walk you through this. Okay. Right. So when we talk about this, is not that one. Sorry, guys. I'm at the right place, right? Yeah. So basically, one of every right, there is in networking, one of the things that you would notice is there's a client and there is a server, right? So server is nothing but a computer running at somebody else's place, like somebody remote. Okay, so it has a IP address, and the client talks to that IP address. IP address is a bunch of numbers with which a client knows that IP address and it talks to them, right? And there is a DNS server which converts the client's name, like google.com, to the IP address, and we connect to the IP address. Okay, so the client, when like on a website, the client knows how to display HTML, how to run JavaScript, how to manipulate the CSS and so on, right? CSS is for styling the content. The color of this one is blue, that one is underline, and so on. That's for the CSS. And JavaScript is to modify this UI, the client side scripting. Like when you click this button, this color should change. All of that is done using JavaScript. So using JavaScript, you can manipulate HTML, you can change CSS and so on. And HTML says that what is displayed where. And on the internet, right, when you are making a call to a server, you use something like a protocol called HTTP. Okay. HTTP is Hypertext Transfer Protocol, which is basically stateless, where we make a call to a URL, it returns an HTML. Okay, or it returns something like JavaScript, object notation, JSON object, or something else like a plain text file. Okay, so on the server side, when the request comes in, what to do with in order to give the response, that is called backend, right? The backend is usually written in Go, Python, and there is a data store, there are databases, there's Memcache, there's so many things, other things, right? So this is a like standard TCP protocol. I'm not going to go into much detail. And we basically are mostly working at the transport protocol. Rest is all below. Now, we basically communicated earlier like this, and now we communicate over the internet. There is no need of going into that. Now, one program or a process talks to another program or a process running on somebody else's computer via the internet. We call that sockets. Okay. What is a socket? Or like in a socket, there is something called a port. Okay, very important part. This is something that everybody should know. When we run a service or a server, it's a program. Okay, a service or a server is nothing but a program which listens on a particular port number. Okay, it listens on a particular port number. And when client is making a call, it talks to that port number. For example, the on a server, there might be an email process running. Okay. Email process could be running, and so usually the email process, we call that service SMTP, Simple Mail Transfer Protocol. So SMTP service is running. It's listening to anybody trying to drop a message here. So it's listening on 25 port. Nobody, if this guy is listening on 25 port, the other process cannot listen on 25 port. Each process can block more than one port, but one port cannot be blocked by more than one process. Okay, 25 port means only one service. Okay, similarly, earlier there used to be something called remote shell via telnet that used to run on 23. A web server, HTTP, usually listens on 80. When we say google.com, okay, http://google.com, the default port we are talking to is 80. If we are doing HTTPS, which is the case, https://google.com, internally that translates to 443 port. Okay, these are something known ports. Okay, then there is something called a POP server that listens on 110 port and so on. Okay, there is a FTP service that listens on 21 port, and SSH listens on 22 port, like that. So every process usually, but they can be changed. They can be changed, and you can run these processes on different ports. Okay, usually any port below 1024 can only be blocked by a process that is running as sysadmin. Okay, any port above 1024 can be blocked by anybody. That's why 8080 is normal port that people, when they're developing, they use 8080 port, because to block an 8080 port, you don't need administration rights on the computer. Okay, so that's a general understanding of ports. And there is something called a DNS server, which takes a name from you like google.com and returns the IP of that. Okay, and essentially these are all servers. Everybody talks to each other using these services. Okay, so if you are talking to a server like localhost :8080, this is the domain name that gets translated by the DNS service into the local IP address. And then this is the port number at which we are listening. Localhost is also aliased as 127.0.0.1. Okay, this IP address means you are pointing to yourself. Okay, you can just test it on a computer. Like, for example, here, you can just say ping 127.0.0.1. This is called a loopback address. Okay. Oh, it's blocking. It's not responding to that. Okay.
You can do NS lookup, I guess.
Okay, so one thing you can test out very quickly. There is a tool called NC, using which you can listen on a port. Let's say I'm trying to listen on 8080. Okay, and it is saying this service is trying to accept incoming network connection. So I'm saying allow. Okay. So like that, right? Now I can talk to this computer. I can talk to this computer and say ANSI localhost 127.0.0.1, and I can say 8080, right? Now, right? So this process is listening on a port 8080, and this process is connected to that server on 8080. Okay, let's just do a quick experiment. I'll just show you a very interesting thing. Okay, and let me log in. Okay. Okay. I keep pressing function key instead of control because I got a new keyboard. Now, let me just go to the server. Okay. I will go to server. Okay. And take this out. Okay. It's a good digression, and I think this was something that was needed. Okay. So don't worry, we will have good time. Okay. Now moving on here. Let's say, where are we? Where are we? This is all good. And let's open a terminal. Okay, let's do this experiment. Okay, so we can say NC listen on 8080, and I'm saying on all the IP addresses. Okay, let's see. Okay, now let me see if I can talk to this server. This is my local computer. This yellow one, this is my local machine. And this is CloudxLab server. You can see e.cloudxlab.com. Okay, I'll say connect to e.cloudxlab.com at 8080. Okay. All right. Okay. It's not letting me connect. Okay. Those who are already logged in onto this service, they can test it. Okay. And okay, let me see NC. Okay. And NC has something NC hostname, port name, and listen. Okay. And del L. Okay. All right, let's see. NC-L-help. Okay. Okay. Source port, source address. Okay. Yeah. NC-L. And we are saying listen on all IP addresses, because in a computer there can be multiple cards, correct? There can be multiple IP addresses. To find out the IP address, you can use a command called ifconfig. You can see all kinds of IP addresses. This one is 172. This one is again, right? There are multiple cards on it. This is a public IP address for this machine. You can see for every computer, you will find this as the IP address. Okay. Now, I can talk to this, right? I can talk to this. I can listen on all of these ports by using this, right? Using -L, I'm saying 8080, and I'm saying listen on all the IP addresses. Okay. And it is not allowing me. Okay. Let's see. Listen and bind on this. Okay. Source address, source port. Okay. There is a way I can NC dash listen. Okay, cool. This is okay now. So I have opened the connection. Locally, I'm listening on 8080. Okay. This is on server e.cloudxlab.com. I can now connect to it using this. Okay. All right. It's not connecting for some reason. It's not connecting. Is it something wrong with my network or my firewall or something? Are you guys able to connect? Anybody? Let me open another terminal. Okay. So there are
no luck. It keeps saying address already in use, quitting.
No, I'm not saying L next time. I'm just saying connect to say localhost and on port 8080, right? This one works. So I'm able to chat with myself. Okay. So this is from Sandeep. Okay. So here you can see. So this is a server which is listening on this port and this host. Okay. And you can talk to it using this. I'm logged in on the same machine. So I'm just saying NC localhost. This is the name, host name of this one, and 8080. That's the port name number.
For me, it says connection refused.
From the remote? Okay.
From the local host, yeah.
From the localhost. Okay. Let's try this. Okay. I'm going to try, say, 4040 port. It's already bind. Okay. All right. Now let's try 4041. Now it's working. Okay. Probably we have not allowed 8080 on our firewall. So you can see now I say -L means I'm listening on 4040. Okay. And then from here, I'm connected to that host and it's printing this. Make sense to everyone?
When it says already in use quitting, so what does it mean?
It means that no two program can listen on it. Okay. On this computer, this program is listening on it. So if anybody on this computer tries to block this, okay, it will throw an error. Okay. And it would definitely throw an error. It won't let you block it. Okay. It's already blocked here. So others can't block it. Okay. So this is my server. And to talk to this one, I'll have to use, right, this format. I'll say, okay, I would say, okay, what was the name? e.cloudxlab.com. It says connection refused. Why? I was able to connect it here. Okay, probably only one client can connect. All right, here I'm able to connect. Is it dead?
Once we use one port, if I'm using
it got killed actually. Yeah.
Sandeep, why are you not in the virtual environment on the other one?
I have not run anywhere the virtual environment because I was not.
Yes, see this MyVenv. Okay.
Okay, doesn't matter because we are not using any Python package as such. Okay.
Sandeep, this like the message broker RabbitMQ or something like that.
We are just creating a basic service. Okay. This is NC is a hacker tool, and people just quickly create a service using this. So we just created a simple service, echo service, which is listening on 4041 port. Okay. And here we are trying to talk to it. Okay. And yeah, now I'll run it. Anybody else can try it. Okay.
So send and receive works on both sides. The question, Sandeep, is if you are using 4041, then nobody else can use it on this machine, or
correct?
Is it
okay. Nobody else can listen on it?
Okay.
Okay. So there can be multiple clients talking to me, as in there can be multiple clients, but there can be only one server listening on 4041.
Via this thing, we can transfer file or anything. NC command.
NC command, yes. Actually, it has a many options. You can try it out.
First time I see that.
Yeah. NC command has been designed to be like a Swiss Army knife. It can be used for all kinds of things. Okay.
Same as the SCP command we are using.
Yes. Yes. This is for creating servers and just checking the network.
Okay. Network.
Okay. Yeah.
When I used NC 004041, So it said
Yeah.
already in use. It means it is you are using. That's why at this point of time, it will not allow my machine to connect.
Correct.
Yeah.
Correct. If you blocked it first, you can try listening on 42. Okay.
I already am using it. I actually killed it, so you can use it if you want.
Okay. No, you run it. Okay. Let me see. Localhost. Okay. What is the port? 4042. Okay. Okay. So yeah, you can see the thing echoing on your screen. No. All right. So this is how the system works. So this one is listening. We just created a server that listens on this, and this one is a client. So I can talk to it using. Oh, it says connection refused. Oh, it got killed. For some reason, it get killed. Okay, so I can see that it came. All right. So this is the philosophy of the ports and these things. All right.
How do we get like which port to use?
Okay. So you can use the command called LSOF. Okay. So you can just search how to find which netstat. Netstat is the command. How to find which ports are being blocked by which service. Okay. So that's usually netstat. People can just go to netstat or
PS-EF, one more command.
yeah, netstat. You can just take a look at netstat and it'll show you that. Okay. So I can just find it out from here, like sudo is like running something as a root or administrator, and then we can say netstat, and then it would give you all the ports that you're listening. It's I think -AP or something like that. Okay, let me just try this. So, man. Okay. Let me see on Mac. What is that? Okay. Yes. Oh, Stack Overflow doesn't open on this computer for some reason.
PS-EF you can try.
I see. So we can say PS-EF. Yeah. You can see that it basically shows
every process.
It is showing that this is the program that is running. But it's not showing the port number.
Port number. Yeah, this is not a port number service. Okay. Yeah.
Okay. All right. Just I think a better thing would be to how do you find out the port number? Usually, yeah. I usually would use netstat, and there are other tools also like nmap and other things with which you can find out the port numbers, who is listening to what. All right. So that's a quick idea about the ports. Okay. Right. So you can basically using Python also, you can simply say import socket and connect to a port number, server number, and then you can connect to it and listen on it and then move ahead. And essentially that's how it is. So basically you talk application to application over the ports. Okay. And yeah, SCTP is the main transfer protocol that you would be most likely using. And it was designed to retrieve HTML images, documents, etc. And the SCTP protocol is something that most of the services, servers, and everybody uses, right? And it's basically a bunch of rules that allow the browsers to talk to the server. Like we send a request in a certain format, and when we receive a response, it has set of headers, it has set of response, it has time, it has cookies, and it has multiple things. So all of that is a part of HTTP specification. Okay, so you can right. It's basically a protocol is nothing but a standard of communication. Okay, and right. So the URL could be anything. Okay. So basically you can take a look at the RFC of HTTP, right? So there is a standard. Usually standard is published as RFC of HTTP. Okay. This is the HTTP protocol 1.1. This is the one that we have been using. It gives you an outline. Okay. It gives you an outline of the entire of what happens, like what are the various kinds of headers that HTTP server can give, how does the body looks like, how message length, and right, the URL structure. There will be how does the like here you can see the URL is starting with HTTP. If you let's say copy paste this URL, right, you can see this is the protocol, whether HTTP or HTTPS, then colon, then double slash, then this is the name of subdomain, another subdomain, and then this is called the top level domain. Okay, then slash, then followed by the resource that you want. Okay, and this could be anything. So, right, on the server when it comes, the server would basically try to match what is that program that need to be run to answer this query. Okay, and there could be more things like question mark, query, XYZ. Okay, so the server would decide that which program to run, and it will give that program all of this data, including the URL, as the input, and server will decide what to do with that. Okay, so basically, that's kind of the internet protocol. Okay, now I mean the HTTP protocol. Okay, each time the user clicks on an anchor tag, it basically with an href value to switch to a new page, the browser makes a connection request to the web and so on. All right, so you can basically make a HTTP request by yourself, and right. So your browser, let's say this is the page, and you click on second page. So browser is making a web request on 80 port, and then this request is called get request. We are saying get me the underlying URL. And then from there, the server replies with an HTML, and browser displays it as a nicely formatted thing. Okay. So I hope this diagram is very clear to everybody. So we clicked on, say, this link. The browser sent a GET request to the web server. Web server responded with HTML and displayed it here. Usually when it's a form submission, you should have a post request. And when you are clicking on a link or opening a page or retrieving JavaScript, retrieving CSS, all of that is a GET request. Okay, be very sure to avoid mixing GET and POST request in your website. If you are designing one, if you're designing a web server, do not mix GET and POST. POST is for the cases where there is a state change. Okay, GET is for the cases where you are okay for the URL to be cached by the browser, by the server, and so on. Okay, but POST you would use in the cases where you don't want it to be cached, right? In case of Amazon, because we confused GET and POST in one of the times in past. Okay, so when somebody was clicking on buy now, that buy now add to cart, when somebody was clicking on add to cart, what was happening is that request that was going in, it was a GET request to the server, add to cart. Now, when you have a GET request, everybody tries to cache it or tries to refresh it again and again. and gives a retry to things. And this is where the problem occurred. So actually on Christmas, because add to cart was causing a get request rather than post, many people received same items 20 times. Okay. And that actually happened because of get request and post request being confused. Okay. So be very clear if it's a form submission or some data is changing and you don't want any server to cache it, right? You use post request. If you're okay for servers to cache it and other things, you go for get request, otherwise post request. Okay. I hope that was very clear to everybody. So these are standards. Take a look at the standards if you are very interested. If you're designing something like what happens when server sends a file download pop-up, right? You must have seen when you click on something, server says you want to save this file, right? That's a HTTP response that is coming from server along with the content of the file. Okay. All right. Now, a request message from a client to a server includes within a first line of the message, the method, and so on. Now, you can make an HTTP request, okay, like this. All right. So this is pretty much, we'll talk about the scraping and other things at a later point of time. Okay. So that's pretty much. Now, moving on. Okay. So we will be making the request to the LLM, whether here. So we'll make from our Python code, that's a client, to the Open AI servers, we will be making a call. Okay. And then OpenAI will give us the text response. We will ask a question over the HTTP and they will reply. Here again, we will, right, this is our Python program. This is going to be, let's say, our Python program who is executing it. And we are asking OpenAI that give me the embedding for this text. And the OpenAI will give you a bunch of numbers. Okay. So that's the entire thing is going to be over the network. Okay. So when it's a text response, we know that we can do a lot of things. But when it comes to embedding, let's understand what actually is embedding. Okay. Embedding is a sort of numeric representation. Okay. So this is a bunch of numbers. Okay. Given a text, it gives you a bunch of numbers. Okay. A bunch of numbers is usually called a vector. Okay. Vector is a very confusing term for everyone. Okay. Vector for a physicist, for a person from physics, it's a direction and magnitude, right? Two numbers, direction and magnitude. Okay. In case of mathematician, the vector is basically list of numbers. Okay, it can have any layers. For a computer programmer, the vector is basically array, right? In Python, you must have used lists. So basically, the vector is a confusing term. It's easier to say that it's a bunch of numbers. Okay. Now, LLM, the secret sauce that we'll be covering, that how does it convert it into vector, we'll talk about that. But okay. A question from Samip is tool like Databricks is vector? Come again? Oh, Samip's question is tool like Databricks is a vector also? No, I think you're confusing it with the vector database, correct? You must have heard vector databases. Yes, right. There's also a vector search, correct. So we'll talk about that towards the end, and I think you will get the feel of it. I can guarantee that you will get that feel. Okay, we'll reach there. Okay, why do you need new way to store a vector? Okay, so it's a bunch of numbers. Okay, it's a bunch of numbers. It's good that you reminded me, Samit. And yeah, I'll explain that. Now, what LLM, the secret sauce in LLM does is it converts text into a bunch of numbers. Now you might say that what's so big deal? We can ourselves also give numbers to them and give out, give out these numbers. Now here's a very cool thing about embeddings. Okay, these embeddings represent semantic relationship between the sentences. Similar sentences are, this is not words, this is sentences. Similar text, we'll just call it text. Okay. So similar text is represented by vectors which are nearby. Okay. So let's take a look. Okay.
Sorry. When you say similar, is it like, for example,
Meaning.
word and words, right? Meaning wise or?
Meaning wise. Okay. So frog and toad, right? And from and Ted. Okay. So basically, if you convert frog into the bunch of numbers, draw it in XY coordinate, then toad, put it in XY coordinates, Ted, XY coordinate, and from. Frog and from have very many, 3 letters similar, but frog and toad will end up close by. Okay, that's the magic LLM is doing. Okay, so LLM is converting frog into a bunch of numbers. If you find the distance between this bunch of number and this distance is going to be very small as compared to this distance.
How does it know? I mean, sorry, I might be jumping this, but
Yeah.
is it no? So is it does it has information about synonyms and
basically it's just a random luck of data scientists. What they were doing is they were training a model to build a autocomplete keyboard. Given a text, suggest the next word. Okay. And when they were doing that, it started becoming so intelligent that it became ChatGPT at the end of the day, right? And then people also realized that instead of extracting words from the LLM, if you just take the bunch of numbers in the last layer, those bunch of numbers were meaningful. Just like it's like instead of you speaking things, we take the signal from your brain and represent them as a vector. That signal, when I say a sentence and you interpret it and we take the signal, that signal would have a meaningful relationship with other sentences. Okay, this is exactly what we're doing. So you can think of it that this is a big brain of LLM. We said we spoke to it one sentence, and then from the brain of the LLM, we extracted this signal, which is basically a bunch of numbers. You can't interpret this signal directly, but what you can do is you can take this signal and compare it with other signals. That's what we are going to do today. Okay. I hope this is making sense, Subodh, so far.
No.
So Sandeep, so
if you said yes, that will be a lie.
Yeah, okay. So how are the vectors created in the first place?
LLM first before.
What?
I feel like we need to first understand LLMs, like how
they
are working or they are hard.
Don't worry. You can just assume that ChatGPT works. and it works because we have trained a model to over and over by feeding all kind of text. What we have done is okay. So basically, you know how ChatGPT is trained? Anyone?
No. That
No.
is my
No.
question. Like, how are
Through
the
the web,
vector
right?
created at the first place? How are the frog and toad? So how are those numbers or the values assigned?
Okay. So think of it, a large language model as lots of a big brain. Okay. What we are asking this big brain is predict the next word correctly. Correct. So the way ChatGPT is trained by predicting the next word. Okay. Now, the whole brain has been trained to predict the next word. When you basically, the way ChatGPT learned from the entire data set is we gave a sentence and asked it to predict next word. If it did not correctly predict it, we tweak its knobs, like the computer tweaks its knobs, we call that training, and then it starts to predict that word. Then again, we feed another sentence, expect it to predict the next word. Okay. If it does not, we keep on tweaking the text, its knobs until it predicts that word. And that's what we keep on doing for all of the texts from the internet. That's what OpenAI has done. Okay.
So Sandeep, there are two parts here, right? We understand based on a lot of training data, we were able to train ChatGPT or whatever model to predict the next word based on the sentence formation, right?
Yeah.
Now that is different from what we were talking here, right? Where we are trying to predict the meaning of the word and then find that the two different words are having same meaning, so they should be next to each other, right?
Yes.
So there is predicting words or sentences. I mean, I believe that if you train a model with 1 million sentences, right, based on understanding of what comes, the probability of which word coming next will be derived from those 1 million sentences, right? But the model will not know what exactly each word means.
No,
Does that make sense?
Yeah, that's exactly what happened. Okay. People, when they fed so much data to it and the model was not able to memorize each and everything, right? It kind of built an understanding of things. Okay. So neural network actually built an understanding of things just like me and you do. So the model was not really memorizing each things. Model was approximating. And while doing that approximation, it kind of started learning the meaning of everything. Okay. Just like me and you do. Okay. Because we have a limited memory. If we had infinite memory, what we would do, we will memorize each sentence. Okay. Similarly, the model has a limited memory, so you kept on feeding it all the sentences from all the websites and asking it to predict the next word, and that way it learned to predict the next word. Now, what scientists discovered was it actually understood the meaning of sentences. Okay, when they instead of extracting a word, they extracted some numbers from the entire brain of the OpenAI of the GPT. They found that those numbers had meaning. Okay, it's a discovery. It's not an invention. It's a discovery that if you train a model like this to predict the next word, it kind of starts understanding the meaning of sentences. Okay. And yes, I think let's keep it there. Be with me. Digest it, that large language models have the ability to give you the meaningful numbers that basically represent it. And let's do this hands-on to digest this fact. Okay. You have to digest this fact that and when you see the evidence, then it'll go settle down well. Okay.
Okay.
So,
All right.
Sandeep, when you say sentence embeddings, so it's an input for LLM or it's output from LLM?
It's an output from LLM.
Okay, but we are giving a sentence as input, right? So that is what we are doing as embedding now.
We are feeding text to LLM. LLM is giving us bunch of numbers. We call them the embedding. Got it?
Conversion of those text into the vectors is embedding, is it?
This output, this bunch.
Okay, got it.
Okay. We're feeding canines, companions, say, and the LLM is giving us these bunch of numbers. This LLM is kind of, we took the brain, sliced the last layer so that it does not output a text, and it just gives us a bunch of numbers. That's it. Okay.
When you say vectors, this is not the vector database that we use for embedding in LLM, or is it same?
This is vector. Vector is a list of number. To store these list of numbers, people like this usually is of size 1023. That's what OpenAI gives. There are 1,000 numbers in this list. To store these 1,000 numbers, we can use a table that has 1,000 columns, right? But that's very inefficient. And you will see that why that is inefficient. So to store this vector, people designed new kind of data store called vector data stores, which are very efficient at storing and searching. Okay, we'll talk about this very soon. All right?
Yeah, got it.
Okay. So to store these things, we require different kind of data stores to do it efficiently and to search. Now, here is a very important fact about it, right? So if you feed canine companions say woof, bovine buddies say moo, feline friends say meow. So they basically end up very close by to each other. Okay, let's take a look. So what people actually, here is a good exercise. Okay. So what you did was you convert, let's say you have these sentences. I like my phone. My phone is good. My cell phone looks good. You computed their embedding, and then you put their you found the distance between them. I like my phone. I like my phone. You see, this is if you compute the distance between the two this list of numbers and this list of numbers, that's highest because it's itself. Now, this is the closest. This is the closest. I like my phone to I like my phone. My phone is not good. This is far. You can see this is far, right? We will plot this today, and then your cell phone looks great, and I like my phone. This is there. Now, will it snow tomorrow? It's completely white. I like my phone. So you can see when you.
How is it far? Sorry, Sandeep. Sorry to interrupt. How is it far? I didn't understand.
So basically what people did was they took these sentences, fed to an LLM. LLM gave them a bunch of numbers. Then from each of these embeddings of these texts, they computed distance of all others. Okay, I like my phone versus I like my phone. I like my phone versus my phone is not good. I like my phone versus. So we computed all the distances. Okay, and then they plotted it. So you can see the distance between I like my phone and I like my phone is very small. Okay, and they plotted it after. This is basically a plot of distances, or you can say similarity. Okay, so you can see the light. In this, light value means there is no relation. Okay. The dark value means there is a distance is very close. Okay. So what is your age and I like my phone is this, which is very light. And how old are you? And recently a lot of hurricanes have hit the US. So this is completely white. There is no relation. But you see this red means there is a relationship. I like my phone is not good. These two sentences have something in common. Okay. So the distance, people found that when they computed the distance between embedding, similar sentences were close by. They had very small distance, and the different things were very far away. Okay, let's take a look at this. Using this, you can do a number of things. Okay, you can build lots of systems with this. First is sentiment analysis. Let's do the sentiment analysis. This is the one that we're going to do today. Okay, now let's take a look at this notebook. Okay, so right now what I'm doing is there is one more thing I want to do. Remember that with syntax we studied while we were reading file. So we are using that with syntax to read the file, and this would contain my OpenAI key. So I went to OpenAI's website, generated the key for myself. I had to configure my credit card, and it gave me a key. Now I read that into this variable. I'll not show you the variable, but you can see it is 51 characters. Okay, it's 51 characters. Now, okay, now, or you can just see first few characters. I'll just show you, let's say up to 5 characters. Okay, so you can see first few characters are like this. All right, now you can even take a look at first 10 characters. So these are the 10 characters of my key. All right, I don't want to show the entire key. Okay, so I have basically whatever key I generated from OpenAI. If you go to OpenAI API keys, okay. Why it's asking me to log in, right? So this is my another account. So you can just basically configure it and create secret key, configure your credit card and all, and it'll generate a key. So this is that key, the one that I'm similar to this is there, right? It has now never been used because I have not configured in this particular account. It is in my CloudxLab account. Now, so it gives you the key. You download it, save it in your file the way I have saved it. I've saved it in this file called OpenAI_key, and I'm reading this file and using file.read, and that's it. So I've loaded it. Now I'm using Python, you can set something called environment variables. Okay, so I'm using the OS package, os.environ. Okay, I'm setting this environment variable. Okay, because OpenAI, the module of OpenAI asks you to do that. Okay, now let's take a look at the OpenAI embeddings.
So this OpenAI key is free for everyone. We can.
No, you have to just configure it. It'll just few cents. Okay, it just costs you few cents.
Okay.
All right. Now, basically what they have done is they have given you this API with which you can basically, configure, like you can call this URL. Curl is a command to download a website from command line. Okay. So you basically call their API by providing this is content type. This is your OpenAI key in the authentication header. And then you can provide the data. You can say that, okay, my input is my input is XYZ. And you also tell that which model to use. Okay. The model, if you're using the heavy model, it will charge you more. If you're using a smaller model, it will charge you less. Okay. Okay. So now when you do that, when you pass your text, it generates something called embeddings. This is called JSON object. It has returned things in the form of a dictionary. Okay. And you can see here, embeddings are bunch of numbers. Okay. These are bunch of numbers. All right. And that's pretty much. Okay. There are many use cases of this. We will talk about it. Let's move ahead. Now, here I am calling, I have installed OpenAI package. From there, I'm importing OpenAI. Then I'm creating a client. And then I have defined a function called get OpenAI embedding. It takes text from you as a pattern, and model, I'm giving it a default value. If somebody is calling this function without the second argument, it will assume the model's value to be text dash embedding dash ada dash 002. Then what I'm doing is removing the new line from the text. And then I am saying client dot embeddings dot create input equals input. I'm passing it an array. Okay. Model equals model. And when it returns, when I call this, it would return the data. I'm picking only 0th value from it. And then I'm picking the embedding. That's it. So this one, if you give it a text, it will return you the embeddings. Okay, let's take a look. All right. So you can see the length of queen, right? We said, we asked the embeddings for queen, and it turned out to be these many numbers. 1,500 numbers, 1536 numbers represented queen. Okay. Now, these numbers, nobody can interpret these numbers. They represent something or the other. You cannot say that, okay, first number represents the gender, second number represents the type of the word or parts of speech or something. No, it does not. Okay. You might say, oh, first number represents language of the text. Nothing is no, it's not there. Now, let's do some good magic with these numbers. Okay. What we are going to do is, all right, let's just move on.
Can I say these numbers are synonyms of the queen word that LLM has learned from the web?
Basically, these numbers represent semantic meaning of the word. Okay. So there has been, here's a cool part about AI. Okay. People were building translators. Okay. Language 1 to language 2. All right. Let's say English, French, Hindi, and German. English, French, Hindi, German. So people were building all kinds of translators, right? You had to build all kinds of translators. And essentially, if you have in world, if there are 1,000 languages, you will have to build 1 million translations, which was impossible, right? So what people decided was that this is impossible to do, that you have to keep on designing all translators. So what they did was everybody decided to, that from English, French, or German, we will convert all of them to a central language. And from that central language, we can do the translation to any other language. Okay. Now, what that central language has to be, okay? In this case, how many algorithms you have to write? 2,000. If there are, in the world, if there are 1,000 languages, you'll have to write encoders, and then you have to write the decoders, correct? Now, question was, what should be this language? Okay, should it be, some people tried Sanskrit, people tried German, people tried coming up with a new programming language called Lisp. Okay, this is how the programming language Lisp was invented. Okay, but none of them worked. Okay, last couple of years research is that this needs to be a vector. Okay, this needs to be a vector or a bunch of numbers. So math won the debate. Okay, none of other language could be basically. People tried a lot and it did not work. None of the other intermediate language. The only thing that worked is this vector, and that's what this vector is all about. Okay, now moving on. So representation of a meaning using a vector seems to be more logical as compared to using any other language. Okay, now, so maths is more universal language than any other language, even better than programming, better than Lisp. Okay, now, so what we're going to do is, since there are 1500 dimensions, okay, we can't visualize 1500 dimensions. So we will use an algorithm from machine learning called PCA. Okay, PCA has the ability to reduce the dimensions. Okay, you can think of it the way when you take the photograph of something, you're converting 3D world into 2D world, correct? Similarly, there are algorithms that can take photograph and keep on reducing the dimensions and can represent 3D objects to 2D, 2D objects to 1D, and so on, right? So this algorithm here, we are using something called PCA, and we are telling that convert the data from 1536 dimensions to 2 dimensions, okay, and plot it. Now here we go, right? So what we're going to do is we are going to compute the embeddings of cat, dog, bike, kitten, puppy, bicycle, aeroplane, helicopter, and so on. Okay? And then we are going to plot it. Cool? Okay. All right, let me just change this a bit. All right. So now, okay, everybody okay so far? We are using the models before learning to build the models. Okay. Right now we use two models. One is large language model, and other we use the dimensionality reduction model called PCA. What it does is it kind of does exactly what you do when you take the photo. You go to an angle, you go to the front of the crowd where there's a maximum variance and take the photo. Correct? When you take the photo of a crowd, what do? You go to an angle where you can see everybody's faces, meaning there is a maximum variance between one person and another, and you take the photo. And that's what it does. Okay? So that's how you reduce the dimension. So we'll have a detailed chapter on this. Okay? So nothing to worry. Now, here what we did was we took these words: cat, dog, bike, kitten, puppy, bicycle, aeroplane, helicopter, cow, wolf, lion, fighter jet. And then for each of these words, we are calling our function that we just designed. And then we are putting all the embeddings into this embeddings library. Okay, let's take a look at length of embeddings. Okay, length of embeddings is 12. There are total 12 words, correct? There are total 12 words. Okay, let's take a look. Okay, and now let's take a look at the length of how big is this? How does this data looks like? Let's just pick embeddings 0. Okay, this is a bunch of numbers that don't make sense. Okay, these are the embeddings of the first word, that is cat. Okay, these are the no matter how many words that you give in the input, it will give the same size output. Okay, this is a bunch of numbers. Now let's visualize this. Okay, when you visualize this, it would try to bring and try to plot things in a way that there is PCA here. Okay, let's do it again. Now here's a cool idea, right? You see this, everyone? Now, you see, cow, wolf, lion, cat, and dog, their embeddings are close by, while kitten and puppy are nearby. Bike, bicycle are nearby. Helicopter, fighter jet, aeroplane, they're nearby. You see that?
So I guess the magic, Sandeep, is in creating the embeddings, right? Means
Yes.
all these
So
are the vectors.
LLM, instead of giving you a beautiful text answer, it's giving us those beautiful embeddings, meaningful embeddings.
And creating the meaningful embedding is the creation of the LLM. Means
yes,
right? Or training the LLM.
After training the LLM starts giving these things.
Yeah.
All right.
Just like we had 1500 something responses for queen, one word.
Yes.
So we embedded 12 new words here. So it's around some 1,000 words and some 1,000 numbers
yes. So 12 rows times 1536. 1536, right?
1536 was for the queen word, right? For
every word, every sentence, for every word, it'll be same.
Oh, is it?
Yes.
How this 1536 number comes? Like, is it fixed for every word?
It's fixed for, yeah, it's same for all the words. And it is a function of which model are you using. Okay. You can go here, you can see if you're using a small model, it will generate how many outputs are generated? Let me see. Okay, embedding size. Okay. Okay. So where is it? Where is it? Yeah. All right. So if you go to their website, it would show. Okay. You can see if you're going to use this particular model, it will generate 3072 numbers. Even if you give empty string, then also it would generate these many numbers. Okay.
And we can also give a full sentence as well.
Yes.
Or just one word. Okay.
I'll show you. Let's take a look. Okay. Let's take a look. The way we did here, we're going to do the same thing for some sentences. Okay. All right. Let's take a look. All right. And then we will visualize it. Okay. Okay. Let's take a look. We'll just call them sentences. Okay. And then we are going to say Bharat Mahan Desh hai. Okay. And okay. How do you type it in Hindi?
You can use Google Transliterate.
Yeah, just translate it, it will give you the ending.
Yeah, yeah. Yes.
No, I think write in English.
Write in English and it will convert it into Hindi. Yeah. Yeah.
Here, yeah.
Yeah.
Okay, let's say. Okay, this time we are going to put these sentences like this. Okay. Okay.
Maybe also write something else, right? Like, yeah.
Okay. And
talk about some other country. It shouldn't come in the same way.
Yeah, like US, Canada, Australia.
okay. Let's say the sky is blue, cow barks. Okay. Or let's just say cow eats grass. Okay. Okay. So we have these couple of sentences, right? And let's take a look what happens. Whoa, not this, sorry.
You need to change the words to sentences, yes.
Yeah. Embeddings dot append. Okay.
In web as well, for I in sentences, not in words.
Oh yeah, thank you. Yeah, sorry. Okay. Yes. So it's not able to show that Hindi characters, but you can clearly see India is a great country. Bharat Mahan Desh hai, and Bharat Mahan Desh hai in Hindi, they have come very closer. Correct? And then we have US and Canada are nearby. The sky is blue. The cow eats grass, buffalo gives milk. You can see very clearly that it understands everything. Right?
So this training the LLM is not a manual task, I assume. It means like just like in medical imaging, like if you have to annotate, then you use actually the nurse, the paramedic staff or the doctors to annotate an medical image, right? Like an X-ray or something. And that's how the learning also happens.
So see, in case of GPT, learning was not labeled manually. It was an semi-supervised task. What you're talking about is a supervision entirely, that we are sitting down for everything, we are curating and so on. But in case of ChatGPT, what people did was they downloaded all the internet's data and gave it the pair. Okay, that this is my sentence, then this is the next word to be predicted. This is the sentence, this is the next word to be predicted. And it learned from that. Okay. And it learned to predict the next word from based on all the internet data. And once it was done, then they basically hand curated the questions and answers. And then they basically again retrained on that data and it started giving good answers.
So it is a lot of manual effort, right?
Where?
Manually, like you have to download and you have to feed data, and lot of data will be
No, everything was automated.
That's where MLOps comes into picture.
Yeah, everything. Why would you see the data? You basically just crawl the entire internet, break down the text into let's say into let's say 1,000 character input and then expected outcome, and then you keep on generating that, and then you keep on feeding it and let it learn to give the next word suggestion and keep on tuning it, and it's just all a big for loop, and that's it.
When you say crawl the internet, means you are talking about the crawl the Google search or big search?
Internet is open for all, right? The way Google is crawling everyone's website, right? Right? It's open for everybody. Okay.
So there are APIs to crawl the.
Yeah. You can just use Python's API. We'll talk about that probably next.
Okay.
You can just download a URL, extract the URL, And from that HTML that comes out, it will give the links, and then take those links, again, go to those links, download the text, and keep on recursively doing it. Okay. So you can basically download all the whole of internet. You can just give it, let's say, 20,000 URLs of websites, and it'll just keep on downloading. Okay. Further, in today's time, you don't need to really download all the URL and crawl it, because all of that is, the data sets are available. Okay. So if you search for the data sets, there is something called common crawl corpus. Okay. The common crawl corpus. Okay. So common crawl corpus. So here, basically this is an open repository. You can download it. Okay. So it has 250 billion pages, and it's free and open source. Okay. So you can basically.
It has nothing to do with for which keyword, which URL you crawl. It is
This entire thing. Yeah, this entire thing.
Okay.
So it has 80 terabyte data. This one is 80 terabyte. This one has 19 terabyte. This one has 8 terabyte data, like that. Okay, so you can basically just download from here and use it.
So sorry, so this is raw data, right? Text of all the crawls, right? It is not analysis or anything, right? It's input data for any model which you may want to create, right?
Yeah. Let's say this is the data that you have downloaded. Okay, this is the data that you have downloaded. Okay, so what they usually do is, okay, right, this is my input. Okay, this is my input. Predict next word. Okay, predict next word. So let me just, so from this, let's say this is the paragraph that you have downloaded from internet. Now for the for training the neural network, it will prepare your code, the OpenAI's code would prepare, this is my input. Okay, this is my input to the model, and it is supposed to predict listed, right? That's the next word, correct? And then given this this text of data, okay, prepare give below. Okay, then okay, so and then basically given this below comma, okay, below comma, okay, and like that. So it basically, this is how the input and output was formed. So from this paragraph, you can see how many, like 50 input sets it will kind of, more than 50 it will kind of extract. Okay, right? For example, the next will be, okay, for this data, okay, what is that? Below. Okay, like that.
Does it really know the meaning, or does it know what word to predict next?
You tell me. Do you think it knows the meaning?
Doesn't seem to. It portrays that
in this diagram, do you think it knows the meaning?
No, the output seems like meaning, but the way we understand meaning, it doesn't like it is understanding that, right?
No, actually, it's our ego that we
understand the meaning.
Yeah, but that's a very debatable. Okay, and there's a entire scientific community is split on exactly this sentence what you said. Okay, while some scientists say that, oh, it doesn't understand the meaning, it just is outputting the words, but other scientists say that, how do you define the meaning? If it is able to group things together, it's able to generate those data points such that they are close by, that means it understands the meaning.
So what basically,
I mean, what
I mean, see this, it translate it able to correlate
exactly
and pair it together. So You can understand.
Exactly. I mean,
Yeah.
okay, understand is a loose word, but it is able to convert into some form where it can interpret what exactly relationship between that word with other words, right?
Yeah.
So I think that's how it is. But anyways, that's
Is it the
Yeah.
black box that of the LLM that how it is correlating?
Yeah, every human is black box. You are black box to me, I'm black box to you. Isn't it? Right? The thing is that everything that grows intelligent would turn into black box. If it is too simple, if you take an insect, you know that, or take a cow, for example, you can predict its reactions. Okay, so the more smaller the brain is, the less is the intelligence, the more is it's easier to predict what's going to happen. Okay, so the interpretability is there for smaller, simpler models, right? But for complex models, interpretability is not there. So as the complexity grows up, the interpretability also goes down. Okay, and as long as it's able to give useful results, I am all okay. That's my take on it. And there are that my take on all of this. Somebody asked me, all of this is that they're useful, and let's focus on what can we do with it. And I wouldn't argue because initially I was arguing and discussing, but I think it doesn't make sense to argue. We have to figure out how we can utilize this thing in order to, in our favor, as simple as that. Okay, that's where we should all apply our brain, that where all we can utilize this thing for our work. Okay, so with that, all right, now.
So just one more question on the interpretability. So is it able to explain, or is there a way to explain why did it came up with the answers that it did?
Simple answer is no. Okay. Yeah. Simple answer is no. And right, there is a lot of research, there is a interpretability, or what you call interpretable AI branch, but it's all rudimentary as of today. So don't worry about interpreting. Okay.
So, Sandeep, coming back to the basic question of this notebook itself, the queen word, it has 1536 words. Initially, I assumed that this is the 1536 is the unique word vectors for the queen.
No, everything has a,
unique.
like if you go here now, right? These ones have the same right direction. So you can say first, right? You can just say for E in embedding, okay? And you can say print print length of E. Okay, so for all of them, it's 1536. It's a function of which model do you use.
Yeah,
okay.
But the count is same, but is it the vectors that it is generating? Is it every time unique for each word, or is it same vectors it is generating
What do
with
you
the
think?
same size?
What do you think?
I think it should be different. Otherwise, how it will differentiate?
Exactly. See, embeddings and so on. So you can see this one is 0th number. Okay, and okay. So what you can do is quickly right, for each of these numbers, let's say for I, for I, E, N, and enumerate, let's say embedding, let's say 0. Okay, is it embedding? So embedding. Okay, and then I'm just printing the difference of both. Okay, I'm saying okay. So where is that thing? Oh, there are 3 Ds in it. Okay. Now see this thing. What did I do? Oh, I was supposed to do embeddings of 1I minus I. Now you can see here, all are different. You can see there are almost every number is different. I printed the difference between one word's embedding versus another. Okay.
Okay.
All right.
So when we say dimensionality reduction in this context, so what we are doing is this LLM is taking same correlation.
No, we are basically converting these 15,000, 1,500 numbers, 1536 numbers into two numbers. Okay. It's a standard algorithm of converting them into 2 numbers. Okay.
Okay.
All right.
So Sandeep, when we are saying translation, right? So let's say there is a language, English and Hindi. So how does it convert them into similar numbers? Because does it go through dictionaries?
No, it has been just trained on that one.
So training using crawling, because when we are looking at a web page, it will be in English or in Hindi.
It has already been trained. It has already been trained, and it has learned the meaning of things the way we learned. Remember how did I learn English? Okay, I actually learned English by reading books, reading the fiction novels. Okay, and I did not learn English by looking at English to Hindi translation, that dictionary. Okay, though somebody actually suggested me that in childhood, but actually I learned by predicting the next word or trying to interpret the sentences. Okay, and that's exactly how LLM has learned. Okay, so it's very
I'm trying to understand that, let's say there is a English word, right? It will get converted to some number, and then there is a Hindi word which gets converted to number. So how does it make sure that those numbers are close? Because they would be different.
Those numbers are
close by.
So yes, so it's basically just magic. Right now, you can just assume that it's a magic. We'll talk about this later when we learn about how the model learns. How does an LLM learn? So those are two big chapters. We'll talk about exactly how to build your own GPT. If you wish to just skip entire thing and just want to see how does it learn, you can basically take a look at this blog that we had written. Okay, and where is that thing? Yeah, this one. Okay. Vaishak's question is, isn't it paid? Your question was with respect to the website data, is it?
No, using the OpenAI key, I guess.
No, I think when we were talking about the data that time, he typed that. So websites data, anybody's data, like CloudxLab's data, you can just scroll. You can just type the command like wget and go to cloudxlab.com. It'll basically try to download that using there are Python code. You can also use Python code to download any website. So it's not really big deal.
Yeah, Sandeep, I was just mentioning about the API key of OpenAI.
What?
Yeah, I was mentioning about the OpenAI key.
Yeah, that one is kind of paid. So you might have to pay, you might have just configure your credit card, but it'll be like few cents, not more than that. And I think it's kind of okay. It is kind of okay just to experience it.
You have to initially pay $5 or $10, and when it balance goes lower than $1, then they'll auto charge.
You won't be able to utilize $5 for embeddings. Okay, these embeddings are the cheap. Okay, the API cost of using the embeddings is cheap. If you're using the response generator, that is costly. Okay, you can take a look at
the embeddings will be generated same for the word like each time, or would it change based on like the language is trained more and all?
No, it will always be identical. Okay. If it is changing, that'll be a disaster. Okay.
So that means like the models are not being trained further on, like so they produce more accurate results.
They would not change the model. Okay. That's why you see the older model they retain. This is a very old model. They have to retain that. Whatever they train new, they give it a new name and keep it separate.
Okay.
Because if let's say embeddings break, okay, if you train a model a little bit, these numbers will completely change. Okay. And if somebody has already prepared it and is generating it, like earlier, somebody indexed entire data, generated all these embeddings, and now one sentence completely becomes different, the entire thing breaks. Correct. So that's why they keep on introducing new model. Whenever they're retraining, they don't change this existing model. They freeze those models. Okay.
So Sandeep, is embedding depends on the model or it is different?
No, every model, if you change the model name, the embedding will be completely different. Okay. There's no
possible to see that dimensionality reduction to 2D, right? Will we be able to see that two embeddings, or is it only possible to view the? We show it in the graph, right?
No, here it is, right? So you see let's take a look at our function here. So first we created an object of PCA. This is the object. Here we have passed a constructor. The number of components is equal to 2. That we want to reduce anything to 2. Then we are using this object here. We are transforming our embedding from 1532 to 2 dimensions. So you can actually just print it and that's it.
Okay.
And
if we reduce the dimensions, do we lose accuracy?
Of course.
So how do we decide what is the right set of dimensions?
As long as this is giving meaningful presentation, that something is good enough, right? It all depends, right? So the thing is, if you reduce the number of values to smaller, it is easier to handle, present, but you lose accuracy. Therefore, you don't always reduce the dimensions, right? We'll talk about this in much more detail in the next one, but I want everybody to go through this particular blog, okay? I would like everybody to go through this particular blog, okay? This one. All right. And we will continue our discussion from here, right? I think it's good that we did not complete everything today. I am leaving it to all of you to start using these things, okay? And we will learn about exactly how these models are working, how things are happening, but right away you can start utilizing the OpenAI embedding, and that is essentially the most important and critical part of the entire AI as of today is where can you utilize these embeddings, right? And therefore, I think what we did today is very, very important. At least now all of you are curious about it, right? You have this question, how is this magic happening? How is this magic happening? Now that will serve as a motivation for learning how a machine learns, how actually machine learns. And then second is how a neural network learns. Then how does an LLM learn? How does it produce a text? We will basically fulfill all of that curiosity as we go ahead. Okay. But as of now, just start experimenting, go through this blog and think about where all can you use it. Okay. Just to get more ideas on where all you can use it, take a look at this nice blog. Okay. From OpenAI. OpenAI's blog is good.
This CloudX blog that you were suggesting is the same one which you suggested yesterday, right?
Correct.
The same thing.
Yeah. So, yeah. I mean, in the previous batch, I introduced this idea of just jumping into sentiment analysis on before jumping into AI, because otherwise, it becomes very long. We talk about that, okay, we will learn maths, then first we'll learn Python, then maths, then machine learning, then deep learning, right? And then reinforcement learning, and then we'll learn about large language models, and then we'll basically use it. So they'll become very long. Okay. And I think things don't have to be linear. Okay. Just learn to use the tool. We will build the tool later. Okay. We will learn to use the LLM. We will build our LLM later. Okay.
Yeah. So are we going to take this towards LangChain and others?
Yeah, LangChain and all, they'll become like obvious to you, right? Right now we are using here, if you see, we are using OpenAI's API, correct? Now, for embedding, let's say Google has come up and Google is saying, hey, why don't you use my embedding API? I'm giving for like 1/10 the cost of what OpenAI is saying. Now you'll have to change the code everywhere, correct? Right? So what LangChain guys did was they created a simpler interface where you can just keep on adding these OpenAI, keep on adding these vendors, and you become vendor agnostic. That's LangChain. Got it? That's LangChain. So they'll become like, okay, it's just common sense. Okay. So I would want everybody to focus on this particular idea. Okay. Right? Just go through this one. Okay. From here, we'll start with vector. What exactly is vector? Then, how do you notate, how would you represent a vector? And then what does it mean by word embedding? Okay. We have already done this part. Okay. We already done this part. Okay. Then we basically, this part is also done. This part is also done. This part is done. This part is done. Now we start with Pythagoras theorem, right? If you have a triangle, how do you compute hypotenuse, right? And then we basically then go about 2D space. If you're given 2 points, 1 point here, another point here, how do you find the distance between them? How do you find this distance? Okay. How do you find the distance? Basically draw the triangle, find the height and base, and then find the hypotenuse. So that's how you find the distance between this point and this point. Then afterwards, basically, let's move on. Same thing can be done. So this is the formula that comes out to be from this. Okay, I don't want you to memorize this formula. I want you to derive this formula. Okay, this is a common thing that we'll memorize it, but I would want you guys to derive it by drawing the triangle and computing it. Because when I'm interviewing, right, I usually give them, one of the thing is that I tell them that you are given 2 points, 1,2 and 2,3. Tell me the distance between them. Okay. And if somebody says, oh, I'll just search for formula and give the answer, I basically observe it very closely that can't they derive the formula? And I would usually also ask, like, can you derive the formula? Okay. And right. So therefore, I would request everybody to think of it like this is x1, this is y1. If you create a triangle, what will be the height and base of the triangle? And then hypotenuse will be that square root of that. Same thing in case of a 3D, let's say from here to here, if you have to find the distance, what you'll do is first find this base, and the base can be found by this triangle, and first find A, B, then you can compute D, you know C and D, and then you can compute E. And that formula turns out to be this, okay? X1, the same thing, like point X1, X2 is difference, Y1, Y2 is difference, Z1, Z2 is difference, and then square of that and sum. Okay, so this is the formula that comes up. And if you have 15 dimensions, if you have 1500 dimensions, the formula will be like this: X1, X2, Y1, Y2, and then keep on going, right? And that's how you can compute the distance between two embeddings. Okay, like cat, dog, car, bike, you can compute the distance, and then you can print it. Okay, so try doing this and try computing the distance between, let's say, a triplet. Okay, try finding the distance between Bharat Mahan Desh hai, India is a great country. Okay, the sky is blue. Okay, find the distance between Bharat Mahan Desh hai and India is a great country. Find the distance between Bharat Mahan Desh hai and sky is the blue. Check which one is closer. Okay. I mean, they're embeddings, not the text. They're embeddings. Convert them into embeddings. Embedding of this one, this one, this one. Try to find the distance between this and this, this and this, and then compare it. Which one is smaller? Okay. And then once you have done that, the next idea would be, we will find the embeddings of the word positive and the embeddings of the word negative. Okay. And then we will find a review from Amazon and convert it to embedding. Okay. Then check whether this embedding is close to the negative embedding or positive embedding. If it is close to positive, then we'll say that this is a positive review. Otherwise, we'll say negative review. Okay. So this is a quick code to generate the sentiment analysis, or sentiment just telling whether it's positive or negative. Okay. That's about it. Okay. So basically, this product is not good. This product is good. If you find the distance of this one and this one, you can see the product is not good, is closer to negative. Therefore, this is a negative review. This is a positive review. Okay, like that. So let's meet next week. I would request everyone in this class to go through this blog and be thorough with it. Okay. All right. And then we'll talk about cosine similarity. Yeah, and then we'll continue from there.
I read that today, but the cosine thing I couldn't understand, the cosine similarity part.
Okay.
Apart from that,
Basically, angle between two things.
I guess maybe I'm too old for this design.
No, it's not. It's not true. Nobody is too old. Okay. Cosine similarity. Okay. Let me ask you. Cos of 0 is how much?
1.
And cos of 90?
0.
Yes. So cos, if there are two vectors, if the angle is 90, that means they are orthogonal to each other.
Right.
Okay. So if you can find the cosine similarity, like you can find the angle between them and cos of that angle, right? So if cos of this angle is 1, that means they're very similar. Cos of this angle is 0, they are perpendicular. Got it? That's all. Okay, that's all we are trying to do. And we will also learn, like, how would you find the cos of the angle? Okay, remember that, go through that formula. Cos of A minus B is cos A cos B minus sin A sin B. Okay, yeah. And cos A cos B plus sin A sin B, not minus sin A sin B. Okay, yeah.
Bad memories.
Huh?
My son is doing all this.
Yeah, you should do this. You should do this honestly, and yeah, and I'm like very okay with asking, like when people say, oh, cosine similarity, this and that, I usually give them like, here are two vectors. Take pen and paper and tell me the cosine similarity. Okay. Don't use any library. And it's very important. It's very important. And right. And like even like a PhD level student cannot tell me like how dot product of two things became cosine similarity. How the cos theta is same as dot product of two vectors. Okay. Yeah. So, and it comes from cos A minus B, that formula. Cos A minus B equals cos A cos B plus sin A sin B. Cos A is x1, cos B is x2, plus sin A is y1 and sin B is y2. Okay. Is that?
We are going to cover it in next class, right?
Yeah.
We have 1 week to refresh it.
Yeah, exactly.
Yeah.
I'm going to take a class from my
I'm
son, I
just
guess.
making everyone feel that they have to, just go back to the books. Okay. Yeah. So
I think
it's very
next week
important.
Sandeep is going to ask us to derive cosine formula. Also, don't use them.
Yeah. I mean, that's a very important point. That's a very important point. Okay. Like know that what does it mean by cosine? And it's very important. Okay. Just honestly speaking, when people say that, oh, we need to study the maths, this and that, the only thing is that we have to forget the maths, not learn new maths. That's the most important part. Like the way we learned is wrong. We basically memorized everything. Okay. You will see that when we talk about differential calculus, you will realize that you did not need to study the entire calculus. Okay. For this. Okay. We'll just focus on a small part of it. Okay. And that's sufficient, more than sufficient. Okay. So I think the next week, let's focus on it and then it'll be fun. And yeah, also look up for the cos A minus B. Okay. Okay. Yeah. All right. So yeah, I mean, it's a very important thing because it's very surprising to me that PhD candidates struggle with the definition of cosine similarity. Okay. And
I won't feel bad.
Yeah.
I won't feel bad anymore.
Yeah. I mean, a recent pass out basically struggling with, explaining the formula, like where did that cosine similarity formula come from? He just looked up on internet and cosine similarity is equal to dot product. And then this is it. Okay. And right. And then when I asked like, where does this dot product, how did it become like this? That's where the entire thing starts falling apart. Okay. So, I mean, I'm very, very shocked to see that many candidates, even in Canada, I think many candidates don't remember Pythagoras theorem. Yeah, that gave me like a shock of my life. Okay. You kept on searching on internet and could not come up with a Pythagoras theorem.
Yeah, if in India you do that, probably government will take your passport back.
Exactly. Yeah, I mean, Pythagoras is.
Yeah. Okay. I taught Pythagoras thing to my kid probably when he was in 6th or so, 5th or 6th. Okay. And I think, and it's needed. I mean, come on. How can somebody not know it? And they call themselves like, master's candidate. Okay. Okay. All right. Wonderful. Good discussion today. And we will see you next week. And by next week, be thorough with cosine theta and sine theta. All right.
Sandeep, unrelated to it, but how I'll get these notes that you are saving?
I'll just
I'm not getting access.
I'll just put it in the same folder. I think right, let me share my screen and do it right away. Just take 5 minutes. Okay. Where was this? Okay, there was this one, right? Class notes. Oh, we have been just adding here, not inside any folder, right? Yeah, just adding here. Okay, I will say add file, and this file is okay. Oh, where did it go? I'll just close this and see where did it go. Yes. Oh, this is not the one. Okay. Yes. Okay. This is one notes. Okay. And yeah, the repository. Okay. Doesn't this blog post represent some? Oh man, there is no repository link to it. Okay.
You can also paste it on the WhatsApp group, something that this particular.
Okay. And I'll just give you. I've put it in another one repository. Just it's supposed to be in there. Okay. Okay. You can in the meantime just take a look at this one. Okay. Right. So I will. This is inside learning.md and inside documents. Okay, I'll just upload right away into the GitHub. Where is it? Okay. This one. Where is that? This today's sentiment analysis also I will upload for now. I will anyway add it in properly. And upload text file inside documents. Okay, these are the two notes that we have. I will go to num. Okay. Okay, I'll rename this sentiment analysis to, what is the date today? 28th July. And okay, I'll just add them. Yeah, it's added. So now it should reflect in this current folder. Okay, we will continue from here. Where is that GitHub? Yeah, it should reflect here. Okay, so you can see 28th July, 28th, these two. Okay. So this repository is something that you need access to, everyone. And that's it. Okay. Perfect. And have a good day. We'll see you next week. Okay. just go through these blogs, go through the notebooks that you find everywhere, and yeah, that should be good enough.
And then you were showing some Drive, Google Drive deck as well, right?
No, which one? Okay, that one, yeah. It should. I'll just ask them to give you the access to the entire project. It should be there in CloudxLab. It's there in there.
Okay.
Yeah, I've created the video and everything. I'll just ask somebody in my team to just add it in element. Give you the permission. That's all. It's there in another course. I'll just add you to that one. That's it.
Yep.
That'll be much more easier. Okay. So this one. And I would recommend everybody to now take a look at the celebrity, lookalike celebrity. There is two of that. One is visual image embeddings, like face of you compared to a face of a celebrity, and you have to find the celebrity who looks like you by comparing the embeddings. Okay, by computing
so for that embedding, right, does it require face structure? Which what I tried to do is, I mean, I did that, but try to do it for any object, right? For example, Lego figure, and try to do it, but it didn't do it for Lego because I think it failed to identify.
It is a function of the model that you're using. Okay, so take a look at, go through, that one uses something called a face net. It's a face recognition network, neural network, and just review their the model, and that will dictate. Okay. Yeah, some of the models are capable of handling all kinds of things. Some of the models are not. All right.
I mean, the model says face. Sorry, model says face recognition, so I presume that it won't have anything else. But I'll take a look.
Yeah, you should take a look. Yeah.
One last thing, Sandeep. Yeah. So we did discuss about the list of assignments like you had given over a period of few weeks or months, right? So do we have that compiled list, or did anyone do that? I just wanted to go.
Can somebody help me with that? Okay. Yeah. Can somebody help me with that? Just for
I can do that, Sandeep. Whatever I know, I'll compile it and I'll.
Yeah. Just fork the repository. I'll take a look and merge it. Do the PR.
Yes. Or can you put that in WhatsApp chat as well?
Yeah, but I haven't done most of them, so I would like to do it now.
Yeah. It's a very good idea, and I think the way there is a problem in physics book called Erudove, I will have our own Erudove for this. Yeah, it's a good exercise. Okay, and I always think that we should just create that list of problems in a certain sequence, and that should be good enough. And we'll just keep it as a public repository for everybody that these are the prompts. And okay. All right. So see you next week. I look forward to have discussion next week.
Thanks everyone.
Have a nice week. Bye.
Thanks everybody.